logic, we need to look right into the heart of the atom. So atoms, as far as the chemists are concerned at least, are made up of 3 different particles. In the heart of the nucleus there are positively charged protons and neutral neutrons. And we can see these on the screen here. So the red ones are the protons, the blue ones are the neutrons. But then circling around we have these electrons. It's the protons and the neutrons that give an element its mass and make it quite heavy. So if you pick something up and say it's heavy, well, that's because of the protons and neutrons. But it's these electrons that are right around the outside, and whenever you touch anything, what you're touching there is electrons. I bet you've never thought of this before, but if we shake hands, we're shaking electrons there. Okay, that's our electrons touching each other there. Anyway, right. What makes an element unique is the number of protons in the atom. We don't really care about the neutrons. And if it's a neutral atom, of course, the number of protons are balanced by the number of electrons. So hydrogen, where are you, hydrogen? That's it. Right to stand up, hydrogen. Okay, so you are the first element, in fact, the most abundant element in the universe. You've got 1 proton. That's what makes you hydrogen. 1 proton and 1 electron for the neutral atom. Sometimes neutrons, but we don't care about those. The next element, on the same row, we go all the way around to here, and we find helium. You have 2 protons. That's what makes you, you. Excellent. And then we come back over here to periodic table. So, oh, you're very good. Lithium. Yes, you've got 3 protons. That's what makes you, you. And so on. That's what we do when we go from one element to the next. We increase the number of protons by 1 and the number of electrons in the neutral atom, and maybe throw in a few neutrons. Now, this is where you come in. You've got your cards here for different elements, so if you're a member of the periodic table, get ready. But to help us with this, would you please welcome, straight from the West End, the cast of the musical Loserville.
Antimony, arsenic, aluminum, selenium, and hydrogen, and oxygen, and nitrogen, and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium,
europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and astatine, iridium, and golden protactinium, and indium, and gallium. And iodine, and thorium, and thulium, and thallium.
Iodine, where are you? Iodine should be up next.
There's yttrium, and terbium, actinium, rubidium, and boron, gadolinium, and iodium, iridium, and strontium, and silicon, and silver, and samarium, and bismuth, lithium, beryllium, and barium.
Barium, very good.
There's holmium, and helium, and hafnium, and erbium, and phosphorus, and francium, and fluorine, and terbium, and manganese, and mercury, molybdenum, and magnesium, dysprosium, and scandium, and cerium, and cesium.
And praseodymium, and platinum, plutonium, palladium, promethium, potassium, polonium, and tantalum, technetium, titanium, tellurium, and cadmium, and calcium, and chromium, and curium.
There's sulfur, californium, and fermium, and helium, and also mendelevium, and xynium, nobelium, and argon, krypton, neon, radon, xenon, zinc, and rhodium, and chlorine, carbon, cobalt, copper, tungsten, tin, and sodium. These were the only ones they found back when this song was written. There are another 60 now, we'll show you where they're sitting.
You stand up as well. Excellent. You did very well. So my whole periodic table should be standing now. But will you please give a round of applause to the cast of Loserville? Thank you very much. Thank you for coming on. Thank you.